Okay, now for the read and got it's for this section. Just as a reminder, we have two different concepts here. Again, these are shortcuts, right? So you can still do it the long way. You can still multiply it out and all that, and combine like terms and everything. But again, these are shortcuts, things that are useful for you, and it's going to be really useful when we do the reverse, when we factor them. So again, if you have a sum of squares here, right? So, or the square of a sum. Almost said that wrong. So a plus b. So if this were like, again, a plus b times a plus b, this is the pattern we follow. And to look at a real example, if x plus 4 times x plus 4, in other words, x plus 4 squared, this is what it looks like. Likewise, if we have a difference, so a minus b, in this case, x minus 3, there's a pattern here. Alrighty, and then here we have one addition, one subtraction, but they're the same, right? So x plus 2 and x minus 2. Again, follows a very specific pattern here. Same kind of thing here. So on this one here, again, an example, the same thing, x plus 8. So x plus 8 times x plus 8. In other words, x plus 8 squared follows a very specific pattern here. So again, you obviously take the first term, square it, last term, square it, and multiply the two middle ones and double. So x times 8, double it, 16x. Again, very specific pattern here. Same thing here, right? So square the first term, so that becomes 4m squared. Square the last term, it becomes 9. And then double the middle, so 3 times 2m is 6m. Double it is minus 12m. So we got a very specific pattern for these. So if I follow that pattern rather than multiplying out. So here, again, I'm not going to multiply it. I'm actually going to follow the pattern because that's my expectation for you. So I take my first term, n. So that becomes n squared. I take my last term. Negative 7. Well, squared, that becomes plus 49. And then multiply these. N and negative 7 becomes negative 7n. Double it, negative 14n. Now again, if you want to multiply it out, you'd get n squared, right? Minus 7n, plus 49. You combine minus 7n and minus 7n, get negative 14n, and you get the same answer. But again, we're following the pattern. So for b, take the first term, that 2x, so square that, that becomes 4x squared. The last term, 9 times 9 becomes positive 81, and then multiply them. 9 times 2x is 18x, double it, that becomes plus 36x. So our goal here is, I know by now you'd better be able to multiply these, but again, this is the pattern. We're going to use shortcuts. Now we can use this to do kind of real life problems. I don't know if these are necessarily actually real life, because I don't think people go, oh, I'm going to throw an X in there, random things like that. But it says a square outdoor patio is surrounded by a brick walkway shown. What is the area of the walkway? So here's the idea. Big square, right? X plus 6 are on the outside. And where did I get that? Well, the inside is X, 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 right? And the walkway is 3 and 3. So here, this X plus this 3 is X plus 6. So the idea is I'm going to take the big square, the X plus 6 times X plus 6, and subtract from it X times X, right? So again, we have to find rather the area of the big one. So that's X plus 6 squared. So oddly enough, that fits into the pattern we're using, right? So that means, again, square the first one, square the last one, multiply, and then double the middle one. So now I have, if this whole thing were just X plus 6 times X plus 6, that would be the area. But when you subtract from it the square, which is X times X, so go back and subtract that X squared, and we get 12x plus 6 feet squared. Again, I know weird algebra problems, so if I say, oh, it's 1 foot, right? 1 by 1 or whatever, I don't know, 30 by 30, it automatically fits right in there. So, in problem 2, suppose the brick walkway is 4 feet wide. What is the area? So, going to be a very similar pattern here. Just a second. The difference is this time the walkway is now 4 feet wide instead of 3 feet wide. So this becomes X plus 8, right? Because 4 plus 4. And on the same side over here, X plus, oops, that didn't quite work out to my benefit there. Also becomes X plus 8 going this way. Notice we're at 8 plus X, same thing, right? So, again, what we've really got is our X plus 8 squared minus the area of the square, which is X squared. And we discussed that up here. So, following the pattern here, this is x squared plus the 64 plus 16, x in the middle. Because again, 8 times x is 8x, double it, 16x. Minus our x squared leaves us with just 16x plus 64. And again, we have to label that, and I'm going to put parentheses around it because the label's for the whole thing, not just the 64. Again, label it as in feet squared. So again, the expectation here is that you are using this pattern. If you don't know what this pattern is, go back and work some and get this pattern down. That's important. So this next problem here, we're looking at mental math. This is another way you can use these kind of things. You know, what is 39 squared? To be able to do it in your head, right? So if you follow the pattern, think about 39 as being 40 minus 1. Well, 40 squared is 1600, right? And then we know we're going to add 1 to the end because 1 squared is 1. And then add these two together. Multiply them first. 40 times 1 is 40. Double that is 80. So 1600 minus 80 plus 1 is 1521. I don't know how much mental that is. That's a lot to keep in my head, but maybe it's without a calculator, without having to straight up multiply 3900, because it's easy to multiply 40 times 40, right? So 85 using mental math, so 85 squared. So if we use this pattern idea, what we get is, think about it, I'm thinking about it anyway, is 80 plus 5, the whole thing squared. And so that first term becomes 6400 because 80 times 80. The last term becomes plus 25. In the middle, right, 80 times 5 is 400. Double that is plus 800. Add it all up, 7225. Again, I don't know how much that's mental math. It's a lot to keep in your head, but, you know, it's another way to get it. Before we actually do problem number 4, I want to throw another one in here as an example, because problem 4 is weird, but we'll discuss that in just a second. All right, so what's really important about this one is the pattern here. I have plus and minus of the same two items, right? So V6, V and 6, plus and minus. That's the important part of this pattern. What that means is the middle term's going to disappear. So, now again, if I were to multiply it out the hard way, right, I'm going to get V squared plus 6v minus 6v minus 36. And if you don't know where I got that, then you need to go back and review some stuff. Okay, so these two middle terms are going to cancel out. I'm going to get v squared minus 36. So the pattern here, v and 6, 1 plus, 1 minus. I square the first term, square the last term with a minus sign, and that's it. That's the entire pattern. So you could literally skip all this stuff in the middle and say, oh, well, I recognize the pattern, v squared, recognize the pattern, minus 6 squared, right, which is v squared minus 36. So here, to recognize the pattern, I have the same thing, x cubed, 8 and 8, 1 plus, 1 minus. So I take the first term and square it. X cubed times x cubed is x to the 6th. No middle term because they cancel out. 8 times 8 is 64. That's the pattern. That's simple. Again, it works only when we have a plus and minus of the same two things. Learn the pattern. It's very useful. It's also very useful when we're going to go back and factor it because you'll recognize it immediately. So to continue with this pattern idea, right, we have the exact same thing here. We have x and x, 9 and 9. 1 plus, 1 minus. That means I take the first one squared, x squared. The middle term disappears because they cancel each other out. Subtraction, 9 times 9 is 81. Done. Same thing with b. Same terms, right? 1 plus, 1 minus. 6 squared is 36. The middle terms cancel out. Minus sign. M squared of m squared is m to the 4th. And finally c, same thing. 1 plus, 1 minus have the exact same two terms. So 3c times 3c, in other words 3c squared, man, I can't spit that out, becomes 9c squared. Middle terms cancel out. Minus sign, 4 times 4 is 16. That's it. Again, if you don't know where I got those, multiply the whole thing out. Give it a go and see that the two middle terms cancel out. Learn that pattern. So again, we can use it for mental math, right? So we're going to multiply these two numbers. I don't know why we picked those two, but the idea is, well, actually I do know. This one is plus 4 on 60. This one's minus 4 on 60. So we have 60 plus the 4, 60 minus the 4. Same pattern. So that becomes the first term squared, that's 60 squared, minus the second term squared, which is 4 squared. So 3600 minus 16, yeah, in your head, 3584. There you go. So the next one, hopefully you recognize, right? We're going to have 50 plus 2, right, and 50 minus 2. Right? So that only works when it's stuff like this, I suppose. So we're multiplying 52 times 48. So what we really get here is 2500, right? That's the first 2 squared. No middle term because they cancel out. Minus 4 because that's 2 squared. So you get 2496. That one I could do in my head, right? There you go.